Hello students, we have learnt inverse of matrix in standard 12. You all know how to find inverse of a given matrix. You also know the conditions of finding the inverse that are applicable for a matrix. But we don't know many times why do we learn all this inverse of matrix or many other things which are related to matrix. Today's topic is very much related to application of inverse of a matrix. It is going to be very much enjoyable session for you because you can apply whatever you learn today in your many different aspects of your daily life and try this as case studies, and let's enjoy this as an application of real mathematics, that is application of matrices to coding and decoding, which is also called as encryption and decryption in case of the study that is called as cryptography. Let's go ahead with this. This is the study of encryption. As I said, what is meant by encryption? Encrypting the data is nothing but coding the data. Now, why do we need encrypting the data? This is a particular need which comes to us whenever we are dealing with the special aspects like some economic information, some special information, something which is very special which you want to preserve with you alone, like the data which you are having your profile with the banks, your many other financial details which are related to the bank, or maybe anything that is related to some defense services, armies, where there are special messages which are to be preserved and which are to be with only the receiver and the sender. Whenever such need comes, we need to have something very special which is called as coding, and coding itself is nothing but the word which is called as encryption. So, we are going to encrypt the data very first. Now, what is the business of matrix here? How does it come into picture? Let us see to all these matters in the further slides. Let's go to this. It is very important to note what are the limitations that we are going to apply. Whatever we learn today is of course not the current practice which is applied in the real field of encryption and decryption, but definitely this will suffice to give you a quite loud and very sound information about how it happens in basics. This must be the basic of encryption and decryption. So, let's go with this ahead. Next slide please. This is one of the most basic coding which I am explaining to you all, which is happening in the beginning stage of the encryption. Now, in matter of fact, this type of coding can be done even by the first, second standard or very preliminary ages of students also. But it is very important first to translate whatever code we want to transfer in terms of numerals, numbers, or numbers transferred to alphabets, we can say. We have 26 alphabets. So, how do we transfer? We have 26 alphabets and we also use spaces in between our alphabets which combines our message to be translated. So, the very basic kind of coding which happens is in this way, where we say A is 1, B comes as 2, C comes as 3, D comes as 4, like that, Z comes for 26. And we can use one more, we can say character, that is space, which is given in between the words, which will be coded as 0. So, where there is a relation between the alphabets and the numbers that we are going to use. Now, what happens for the numbers which come after 26, I am going to explain you a little later. Let us go with this basic 26 and one more code which we have defined as character space as 0. Go ahead. Let us have one message. I want to send my message to my receiver which says God exists. Now, God exists, G-O-D-E-X-I-S-I-T-S. Let us see this God exists translated into number of numerals. G for 7 with reference to the previous table that we referred. O15, D4, space comes for 0 as you know, E is 5, X is 24, I is 9, S is 19, T is 20 and again S comes as 19. Can you have this number series which is now translated as all alphabets transferred into numbers? Now, let us write this in matrix form. I have coded this as a matrix which is of size. Can you see the matrix B which is 7, 0, 9, 19, 15, 5, 19, 0 and 4, 24, 20, 0. If I go with this message, now why this specific choice? Is there any restriction to say that my matrix B should be like this only? Or can there be something different which can be written for this matrix B? Let us see to this in detail, which is very important for us. B matrix I have taken in terms of 3 rows. Can you see this? Let us specify to, or let us stick to the number of rows, and I want to give you a specific attention on number of rows first. Here we are saying the number of rows are 3, or I want you to make it limited to 2 or 3. The reason is the choice of the next matrix, that is called as encryption matrix. Can you see the next matrix A written below as 1 2 1, 1 1 1 and 2 1 1, which has a determinant value equal to 1. Now what is the relation between this A and B? This encryption matrix is a matrix which is going to make your coding more perfect. I have already coded my message in terms of numerals, numbers, but if somebody tries with some trials and errors, he can easily decode it and understand what is the message being translated, because it is a very basic and very raw kind of coding that we have done. So what we are going to try is, we are going to impose or induce this matrix A on this matrix B, and when the multiplication is going to happen between A and B, I am going to get something more safer code which will be in the matrix form as A into B. Now that is where comes the picture, or comes the main role of choice of number of rows. Everybody knows when we can multiply 2 matrices. We can multiply 2 matrices provided the number of columns of the pre-matrix matches with the number of rows of the next matrix, that is the post matrix. If A has 3 rows, then B must have 3 columns. Everybody knows this choice. Or else we can say, if A has 3 number of columns, as we say, then similar number of rows I am finding in the post matrix, that is matrix A. And that is where my choice is specific for choice of rows in the B matrix. If I exceed it to 4, number of rows as 4 in the matrix B, then my choice of A matrix is going to be 4 columns. And as I want this matrix A to be a non-singular matrix where determinant should exist, and also the choice is more specific because further I am going to use the inverse of matrix A, which is my own choice as a key matrix. I am going to call it as key. Can you use see the bracket, also called as the key, because that is going to decode my matrix. And that is why if I choose a matrix of A as 3 rows and 3 columns, obviously as it is a square matrix, number of rows and number of columns are going to be equal. And that is where the matrix B, if it is of 3 rows, my multiplication becomes easy, as well as whatever I am going to do afterwards as A inverse will be easier affair for us, because calculating inverse for 4 by 4 or higher side of matrices is a very difficult kind of business. Of course, I think you understand what is I want to explain you here. Let us go ahead with this A matrix. Next, if you see here, I have calculated that multiplication A into B. That means I am imposing or inducing matrix A over the matrix B. If I multiply these 2 matrices A and B, I am getting the output as the next matrix. Can you see equal to? Can you see whatever numbers I am getting in that matrix AB, that matrix AB, which is coded message, goes in a linear manner, not in a matrix manner, as 41, 26, 33, 34, 29, 29, 67, 48, 57 and like that up to 38. Now this linear message of course will not give any feel of the message that we want to translate as God exists. If you understand this is the business we wanted to try as encryption of a given matrix or coding of a given matrix. I hope there are no doubts with this. If this is clear that how to encrypt a given matrix, how to code a given matrix, can we go for decoding now, which is called as decryption of the matrix, decryption of the code. Now how it will happen? Now whatever matrix A I have chosen in the earlier slide which we said, which has determinant equal to 1. Now why determinant is 1? Now why the size of that size part we have explained. Now why the determinant is 1? As you know, if I want to decode this matrix, I am going to use the key matrix in inverse manner. I will calculate A inverse. I have calculated there, you can see on the slide. A inverse matrix. If this is the E inverse matrix, you can see the definition is 1 upon adjoint of, 1 upon determinant of A into adjoint of A. If determinant A remains 1, that means there is no scalar outside the matrix. That makes my matter of multiplication very easy, and that's why the choice is determinant. If you choose as +1 or -1, it makes most of the things most easy for us for multiplication of matrices. So let us be very specific about choice of the matrix as coding matrix or encryption matrix or key matrix, which is of determinant, very easy as +1 or -1. I hope you are clear with this now. With this, if I find A inverse using the definition 1 upon determinant of A into adjoint of A, that is my A inverse. Now this A inverse, if I multiply with this AB, means the matrix C, which I have written as coded matrix. The pre-multiplication of A inverse means I am calculating A inverse AB. A inverse AB, pre-multiplication of A inverse will nullify A inverse A, which will give me the identity matrix, because A inverse into given matrix, A matrix, is going to be identity matrix. And what is going to be with A inverse C? It is going to happen as A inverse AB means I into C. This I into C is nothing but the matrix C. This the matrix B, I mean to say, A inverse AB, A inverse becomes 1, that is I matrix, and that is where I come across the B matrix, which is the original matrix, if you remember, is 7, 0, 9, 19 row wise. If I go column wise, it is 7, 15, 4, 0, 5, 24, 9, 19, 20, 19, 9, 19, 0, 0. This is nothing but this. If you translate again in terms of that first table we referred in the slide 1, going back to the alphabets, 7 refers to G, 15 refers to O, 4 refers to D, 0 refers to space. That gives me my God dash, and then I come to 5 as E, 24 as X, 9 as I, 19 as S, 20 as T, and 19 again as S. Does it give you that God exists? Now what is happening with the last two 0 zeros? Whatever number of spaces remain after my message is translated doesn't affect the message at all, because that is not referring any space in between. Spaces later on or spaces before are not going to change the message anyway. So the message gets translated. What I mean to say, to complete the matrix B, we have used 2 more zeros, which completes the size of the matrix, the number of positions which we wanted to define. This is all about encryption and decryption of the matrix. Let us explain it more easily with a key matrix as a 2 by 2 matrix. Let's see to it. Let's go for the next one. Let's go for one more. This was a negative kind of coding which can be explained to you later on. One more, please go ahead. One more. One more. Another. Ahead. Please go ahead. Please go ahead. Yeah. This is one I wanted to explain with size 2. The message that we want to send as is secret code. I have translated the message using the similar kind of coding, the basic coding, where S comes for 19E for 5, C for 3R for 18E for 5, T for 20, space is 0, C is 3, O is 15, D is 4, and E is again 5. Now this time what I have tried the B matrix is, there are not 3 rows, I have chosen only 2 rows. And that becomes 19, 5, first row, 3, 18, 5, 20, 0, 3, 15, 4, 5, 0. The last 0 is just been used to complete the size of matrix, otherwise it is space ahead. So we can use number of zeros as per the need of the matrix that we want to complete. This is a matrix of how many, what is the size of this matrix? There are 2 rows which are more important for us, and how many columns are there? 1, 2, 3, 4, 5 and 6 columns. So it's a matrix of size 2 by 6. Number of columns doesn't matter, but number of rows should be very specific, because that is going to decide the size of your key matrix. What is the choice we have done? Now this key matrix is our own choice. Naturally, because we want to preserve our message, we want to translate the message in our own way. We don't want it is getting leaked in anywhere. So this is a key matrix, and that is why the word is key matrix or encryption matrix. What is this matrix we have taken? It is 1, 2, 1, 3. What is the mod value? It is 3 minus 2. Principal diagonal minus off diagonal multiplication gives you 3 minus 2, that is 1. specific choice again. I explained you mod A, if it is 1, that means there is no scalar multiplication remaining outside the matrix. Now, let us encode the matrix in a more perfect manner by imposing this A on this B matrix, as I explained in the earlier example, right? Let us go ahead. A into B. Now, when you encode this, when you impose or induce this matrix A on B, it translates to C matrix. So, what is C matrix this time? As per the multiplications rules or multiplication procedure, it comes as 29, 34, 39, 57, 45, 65, 6, 9, 23, 27, 5, 5. This is encoded matrix. Now, this encoded matrix is transferred to the receiver in a linear manner, not in the matrix manner. So, I have written that line which is transferred to the receiver. Once it goes to the receiver, then it comes to the job of decoding the message. Now, decoder also need to know how to decode it. That means he needs the knowledge of key matrix. Rather, he also needs to know that the key will be opened only when I know A inverse, otherwise it will not be opened. So, it is very important that the inverse of key matrix exists. That means it needs to be a non-singular matrix. I explained you earlier also. So, mod A is not equal to 0 means it is a non-singular matrix. And as it is of size 2 by 2, the multiplication is more easier as compared to the earlier example. Can you see that? So, what is A inverse this time? It is 3 minus 2 minus 1, 1. I multiply this A inverse to this C matrix. And what is C? You all know C is A into B. C matrix is A into B. A inverse A into B, what it will give you? A inverse and A, the product becomes identity matrix, that is I matrix. And what is I into B remaining matrix? Any matrix multiplied by identity matrix is the same matrix, that means B itself. So, the answer is nothing but the B matrix. Can you see? B is A inverse into C. So, what you get is 19, 5, 3, 18, 5, 20, 0, 3, 15, 4 and the last column if you read 5, 0. Now, this is the decoded matrix. Now, how it is again received? It is received in a linear manner in this particular fashion, where I come column wise 19S, 5E, 3 is C, 18 is R, 5E, 20T, space 0, 3C, 15O, 4D, 5E and again space comes, that is 0. So, is it not a secret code which is being translated, which is being transferred? So, this is how we can try coding and decoding the matrix. Now, the one fact which I wanted to explain you in more details, is it the only kind of coding which can be used? Is it the only kind of way where we can apply this A matrix or coding of the alphabets and all? No, you can do it in a several number of ways. I mean, you can invent number of ways of choosing the A matrix, coding the basic message in terms of numerals, where you can try the A inverse matrix. So, for which there was an example in backwards, if you see, it has negative kind of coding also. It has negative kind of coding also. Going ahead, just one concept let us get it explained, which will be definitely useful for you, where the product AB, whatever we have, if the product is coming, the number above 26, then what to do? If the number that is product of AB has the characters which is above 26, where our definition of coding is over, because we have defined only up to 26. What to do about 27 and other numbers? That the product can be any number, above 27 also. It can be negative also, positive also. What to do with that? That is translated or that is answered in the next problem. I will just take some minutes to explain the last kind of thing, how to translate the bigger numbers more than or above 26 and still get the message translated. Let us see to this. If you see, for greater security, what is done? Modulus 26 mathematics. It is called modulus 26 mathematics. The numbers which are bigger than 26 are divided by 26 and then translated. How? Let us see. Next. I will just directly explain you in the example. If I am not using space in between, suppose there is no space between the alphabets, that means I am remaining with 26 characters. If I am using space, then I am with 27 characters. Are you clear with this concept? If I am using space, there are 27 characters. If I am not using space, I have only 26 characters, right? If I am using 26 characters, then what will happen? I will have to define or divide every number in matrix AB or the final matrix that you get by 26. And then the remainder will be written in place of the answer, which gives you again the coded matrix or the final decoded matrix. How this is possible? Let's try to see this. I have given here the message, the coding pattern using 27 characters. 27 means 1 is same as 27, 27 is same as 53. Why? Because the difference between 1 and 27 is how much? 26. And difference between 53 and 27 is again 26. So, I am going with this. You can see B is 2 or 28 or 54. I can add another at 26 and write the next decimal, next number. So, like that I will divide by 26 and whatever number comes as a remainder, that will be replacing that particular matrix. How? Let us see. Next. I will go directly to that part of the last matrix that we get. Let us go ahead. Let us see to this. The professor is evil. Is the message want to be translated or transferred? This is the B matrix. The B matrix is coded matrix. Basic coding. This is being transferred with the same A as 1, B as 2, C as 3 and like that. So, this B is T, H, E, P, R, O and everything translated in number manner, restricting the number of rows as 2. You know the reason now. I am not going to explain it again. A is the specific choice been made 5, 6, 2, 3. 2 by 2 matrix, because as the number of rows here are 2, there also the size being 2 by 2. Then C is A into B. This is imposing A on B matrix, inducing on the B matrix. So, what is the encrypted matrix C that I get? Is 148, 121, 180, 60. Can you see the bigger number of series that we get after loading that matrix A on B? If this is so, then what is the meaning of 148 if I want to translate it in alphabet? For this particular query, what we do is we use that modulo mathematics. Can I divide this 148 by 26? If I divide 148 by 26, let us see in the second slide what happens. Modulo 26, 26 characters using. If I divide that 148 by 26, what is the remainder? The remainder comes as 18. Are you getting this clear? If I divide 148 by 26, the remainder comes as 18. Let us go to the back. If I use one more simpler one, say 64, the next one, column row 2, first column, 64. If I divide 64 by 26, I get 26 2s are 52. If I subtract 64 minus 52, what I get is, next slide, 12. The remainder is written here. Now 12 cannot be of course obviously divided by 26 ahead. So whatever is the remainder is written here in terms of the matrix, which is still called as the matrix C. Now this is done just for the sake that whatever we have done is the effect of that matrix which was chosen of higher side of determinant. Can you see A matrix one slide before? 5, 6, 2, 3, 15 minus 12, what is the determinant? Determinant is 3. This time determinant is not 1, that is giving you that scalar effect multiplication on this matrix AB, and that is nullified dividing that particular characters by 26 and reducing it to the next one, reducing it to this particular matrix. Now what to do later? Again inverse of A. Let us go ahead next. If I multiply A inverse with this C matrix, what I get is again the translated message. You can see the professor is evil. This is A inverse into C matrix. Whatever matrix we got, we multiply it by A inverse, and then we get the message translated, the professor is evil. Wasn't it interesting, students? It is really very happier and enjoyable aspect to learn such things where you actually know the applications of mathematics coming into reality. Can we have a case study done on this? Use some negative kind of coding. I am giving you one homework today. Let us code it this way: A as 1, B as minus 1, C as plus 1, D as minus 1. okay, E as +1 and F as -2, and continue this way and code the message, and then the decoding practice goes in a similar fashion as I explained you. Is it? I think you all understood today the aspect of coding and decoding, encryption and decryption. This is called further as a study of ciphers in terms of cryptography. Let's learn about it in the next lecture. Thank you.